In this video I show you how to run a mediation analysis with the new process version 5, including assumptions checks, because that's the big advantage of the new process version, that now you can check most regression assumptions within process. In order to use process you have to download it, there you get an R file, and each session you want to use process you have to run this R script. It takes a minute or two, and when it's finished, process is initialized and you can use this specific function. First I import the data. Here it's a very simple data frame with an independent variable, mediator, and a dependent variable. First let's look at the conventional R syntax for process model 4 for mediation analysis, how it was used up to process version 4. This is still valid with process version 5, but there will be additional parameters. So we use the function process, data, and then the name of the data frame, y, x, and m for the dependent variable, independent variable, and mediator. The model number 4, I recommend using model BT. There you get bootstrapped confidence intervals, not only for the indirect effect, but also for the A path, the B path, and the direct effect C prime. I would set the number of bootstrap samples to 10,000, and I would set a seed value. There you could put in any integer number. The result of that is that each time you run this model, you get the same bootstrapped results. And you could request an estimation for the total effect C. That is the effect from the independent variable on the dependent variable without taking into account a mediator. In this model I don't have covariates. If you had covariates, you could include them in the model with this command. Now let's look at the additional parameters that you can use with process version 5. The most important one is this one, diagnose equal 1. With this we will get all kinds of regression diagnostics as a part of the output. We won't get a regression diagnostic for linearity, we'll deal with that later, but for the other regression assumptions you get very helpful diagnostics. You could use stand equal 1, there you get all kinds of standardized results. And describe equal 1, with that you get descriptives and a correlation table for your variables. Let's run this. First the descriptives and the correlations. Then the model for the A path. The most relevant information is here the effect of the independent variable on the mediator. It's significant, so we have a significant A path. Here are all kinds of effect size measures. Stand yx, that's better, the standardized regression weight. But you get a number of different other standardized values as well. And then the crucial new thing, regression diagnostics. First you get information about the range of the residuals. Oftentimes you look at T residuals, that is studentized residuals, and if they all lie within -3 and +3, you would conclude that you don't have problematic outliers. Then for normality, you could look at skewness and kurtosis. For those measures there are different cutoff values in the literature. I put in a source for that in the video description. This here is an overall measure for regression diagnostics. If it's not significant, it's a good sign. I don't really use that. Then again for outliers, most influential observations, diff beta. So here we can see for the A path, the largest diff beta is for case number 26. And you see it's extremely small. So here we clearly don't have a problem with outliers. Multicollinearity, that's not an issue if you have only one predictor. Otherwise you would look at the variance inflation factor here. And for homoscedasticity, here you get the Breusch-Pagan test. It's not significant. In general, I would use the robust version, so we don't have heteroscedasticity. Then the same for the B path and the C prime path. Mediator on dependent variable, that's the B path, it's significant too. Whereas independent variable on dependent variable, the C prime path is not significant. Again, the standardized values. And again, the regression diagnostics. Here the variance inflation factors are relevant. And in general, a cutoff value for the variance inflation factor is 10, so this is above 10. However, there is literature that says that that's not that big a problem. There's a paper by O'Brien that makes that point quite convincingly. I put a reference to that paper into the video description too. Then the total effect model, that is the effect from the independent variable on the dependent variable without taking into account a mediator. It's significant, and again, the usual regression diagnostics. And the crucial information here is the indirect effect. We don't get a p-value there. We only get a bootstrap confidence interval. So if the confidence interval does not include the 0, then we have a significant indirect effect, which we have in this case. So we have a significant mediation. And here we get the diff beta for the indirect effect. That is, the most influential case when it comes to the indirect effect is case number 81. But if you look at the size of the diff beta, you can see it doesn't make a difference if you look at the limits of the confidence interval. The indirect effect is a B, an unstandardized regression weight. If you want to report a beta, a standardized regression weight, here you get the complete standardized indirect effect. And we additionally requested bootstrap results for the A path, the B path, and the C prime path. So those results would be valid even if the normality and or the homoscedasticity assumption were violated. If you want to do even more regression diagnostics, you could save diagnostic information with the save equal 4 and assigning the result of the process function to an object with the name you choose. As a result, you get a list with the diagnostics, one table for the model for the A path and a second table for the model for the B path. Here I look at the first 5 lines of the table for the A path. We get the case number, we get the variables. For the A path only independent variable and mediator, predicted values, different types of residuals. So with those information you could, for instance, look at a histogram or QQ or PP plot for the residuals assessing normality, or you could run a scatter plot with predicted values and residuals to visually assess homoscedasticity, and then you get all kinds of outlier diagnostics. I think interesting is Cook's distance and the diff betas. Here diff beta 0 would be for the intercept, that's not relevant, but diff beta 1 would be for the A path. And you get a diff beta for the indirect effect, i.e. And that's actually the most important information. Are there observations that have a very high influence on the indirect effect? And the same for the second model, that is for B path and C prime path. Again, the variables, predicted values, residuals, and outlier information. The main thing that's missing from this assumptions testing is the linearity assumption. For that, we run scatter plots. So independent variable mediator, independent variable dependent variable, and mediator dependent variable. And if you have covariates, of course, for the covariates as well. For instance, covariate mediator and covariate dependent variable. First scatter plot, that looks okay. That looks fine as well. And that as well. So linearity assumption, there is no problem here. That's it for mediation analysis with process model 4 in process version 5 in the new process version, including assumptions checks. Thanks for watching and see you in the next video.